So what is this question? So there is some parliament, and this question will contain a glimpse of graph theory also. We will, whatever we need, we'll do it here. So don't worry if you don't know graph theory. So in a parliament, each member has at most 3 enemies. So clearly we are not talking about India. This is some other country. Okay. And we want to show something about this parliament. We can split the parliament into 2 houses. So I'm just reading the question. We can split the parliament into 2 houses such that every person has at most 1 enemy in their own house. So this is a very, a very patriarchal thing to say. But okay. This is, each person has at most 1 enemy in their own house. So forget what this question is saying. For once, let us try to model this question. Okay, so some animation is there. So here's the way to model the parliament. So these members, right, who are sitting in the parliament, we are going to think of them as nodes or dots. So it doesn't matter where these dots are. Don't think too much about the geometry. There are some dots. Okay, so in this case, the parliament has how many? 7 people. Okay, so this is person 1, this is person 2, this is person 3, and person 4. So these are called nodes or vertices. So these dots are called nodes or vertices. So these are just names given to them. And now see, we want to capture what? People being enemies. So being an enemy is a mutual relation. Okay, this is something that I am stating. Meaning that if I am your enemy, you are my enemy. It's not like a crush. This is really mutual. So if you are my enemy, then I am your enemy. If person 1 hates person 2, then person 2 will hate person 1 back. So how do we capture this crazy situation? We capture it via the means of a graph. Okay, so this is the graph of the situation. So what is a graph? A graph is just a collection of nodes and edges. So nodes, I already told you. What are edges? Edges are just connections between the nodes. I'm not going to tell you what they are formally because I don't think that is going to be very helpful anyways. Connection between nodes. So here the connection implies that P1 and P2. So this edge implies that P1 and P2 are enemies. Okay. So P1 could have a different enemy, P4. Okay. Then P1 could have another enemy, P3. But they can't have more than 3 enemies. That is what is written. Then P5 could have just 1 enemy. I mean, some crazy thing could happen. P3 could have P7 as enemy. P6 could have no enemies. They could be like some president or somebody titular, not doing much. So this graph, let's say this is the graph of the situation, that all the enemy relations are captured here. So is this modeling clear? Is this modeling business okay? Is it clear? So if there is a question or something is not clear, write in the chat or speak up.
Middleman said yes. Ishan said yes.
Okay. And Shubhajit also, I think, knows these things. So let's come back to our question. Oh, just missed it by a little bit. I hit it by a little bit rather. So never mind. I can delete this part. So now we want to show that we can split the parliament. So what would that mean? That would mean that we have 2 rooms. So these are our rooms. And these nodes, right? The nodes that are given here in the diagram, these go over here. We can split it. We can split the parliament into 2 houses so that every person has at most 1 enemy in their house. So it's not being demanded that it's an equal split. Nothing like that. So there were 7 people in our example. So maybe the split could be 5-2. Okay. There is some way. So this is house 1. There are 2 houses, house 1 and house 2. We have put some people in house 1, some people in house 2 in such a way that within house 1 and house 2, every person has at most 1 enemy. So if you look at this person, let's say person 7 has gone to house 2. then person 7 can have at most one enemy. They cannot have a second enemy in the same house. एक ही जन से दुश्मनी होगी उस घर में, दो से नहीं करनी, ठीक है ये. So we have to show this is always possible, irrespective of the number of people, irrespective of how their enemy relations are, this should always be possible to do. So is the question clear? Okay, so let's move ahead. I'm going to again do this. I'm going to initiate your thinking process and leave you in between, and then you fill in the blanks. So how would you do? You would again follow Polia's advice. You'll start for small values of n. So 1, 2, 3, nothing will happen. We'll always be able to do it. Like in this case, there is not much gain by looking at these smaller examples. But because you see, if there's 1, 2, 3 people, then nothing. Do any kind of thing. It works. So I think the first non-trivial example is 3. So if there are 3 people, what can happen is that you have a full triangle, like these are the enemy relations. So everyone is an enemy of everybody else. But in this case, you can see it's very easy to split. Right? You just make this split. Let me use the green color to see. So this can be house 1 and this can be house 2. This split works. Okay. So you can, since this is a class, I cannot keep doing the smaller cases, but you should do this to experiment and get a feel. But let's say we have some value of n, maybe like 7 itself, right? There are these in-between values which are skipped. And again, we will follow our template. We will say that, okay, somehow someone has drawn this enemy relations, this graph, in such a way that no matter how I decide to split, I always fail. Okay, what does that mean? That means that you start with this relationship graph and you start with any partition. So let's say we decide to take one very simple partition. We can start with any partition. We take this very simple partition in which person 1, person 2 and person 3 are in one group and person 4, 5, 6 and 7 are in the other group. We just start with this partition. And we realize that this partition does not work because the person is saying, no partition is going to work. Every partition fails. This is a counter example to the claim, right? So let's say that we look at person 4. So there must be one person in one of the houses who has 2 enemies. That is what it means for the question to fail. That some person in some house has 2 enemies. Let's just assume that person is person 4 in house 2. So person 4 is person 4 is connected to person 5 and person 4 is connected to, let's say, person 6 also. These are the enemy edges, you remember from the graph we had drawn. These edges are the enemy edges. And person 4 can have some more enemies, maybe in the same house, or he can have one more enemy actually in the same house. And let's assume that he has an enemy in the different house. He has an enemy in person 2 in the house 1. So these are his 3 enemies. It was not necessary that he had 3 enemies, but I'm just assuming that. We want to improve this situation. This is clearly not a good situation. We want to make this local improvement. What is the most natural way to make this local improvement that you can think of? So I'll give you guys 30 seconds or maybe a minute to think of it. It's not very difficult to at least suggest some local improvements. Then we will see if we can even think of a parameter. Okay, so are there any suggestions as to what can be done to improve this situation?
Shubhajit has one. He says we can shift P5 or P6 to house 1.
Okay, so shifting P5 or P6 to house 1 certainly is a good suggestion, that it seems to take care of this issue. So the suggestion is to move P5 to house 1. Are there any other suggestions?
That's it.
Mrinmay and Ishan, do you guys follow what we are doing? We are asking you for ways to, at least for person 4, make the condition feasible. That is, person 4 should not find 2 enemies. Yes, Abhishek?
Identify pairs of enemies, Ishan.
So all pairs of enemies, Ishan, are given by these edges. So I'm not sure if this part was clear. So so you see, P1 and P4 are enemies. So they are drawn, an edge is drawn here to signify that something happened. And we lost Abhishek and Ishan at the same time.
So Ishan is saying that identify pairs of enemies and accordingly put into the respective houses.
No, so we don't. I don't quite follow what that means, because pair of enemies are given by the. So this is a graph. Here is the graph. Ishan. Oops, sorry, 1 second. So here is the.
So I think what Ishan is trying to say is just go to this first person and then go to his enemy, keep them in different houses, then again reiterate this, like if you are trying to fill 2 houses. I think he is saying that.
Okay, so you start with P1, look at their enemies, put all the enemies in the different house, right? But this could already backfire, Ishan, because it is possible. See, it was possible that P2 and P3 were enemies, and P3 and P4 were enemies. This is quite possible, in which case you can see that if you put P2, P3 and P4 in the same house, because they are all enemies of P1, there is a problem that P3 already has 2 enemies, P2 and P4 in the same house. Right? You are suggesting that this could become a house. So you need to be careful as to how to do it. A straightforward way won't. Maybe you have a cleverer way. But in any case, here the question being asked is, how can you help P4? So is that clear, Mrinmay? How can you help P4? Just a very simple question. So Shubhaji suggested, why don't you move P5 to the other house? दुश्मनी है जिससे उसको दूर कर दिया. P5 has been moved to the other house. P6 could have been moved. Or P4 could himself move. घर ही छोड़ दिया. So let's see what is the result of these improvements.
Nirma is saying that it is clear to me, but can't think of a way. Move P4 to house 1.
Okay, so Nirma's suggestion is to move, which is also a good suggestion, is to move P4 to house 1. All right. So what will be the effects of these movements? So there are 2 possible suggestions. Obviously, we can't use both of them because otherwise P4, P5, actually we might be able to use both of them also. But in any case, there are many options here. Yes. So, so this is P1, P2, P3. So I will explore one of the options. You guys are free to explore the other options. I think all of them will lead to a solution, possibly. So
I should clarify. So Ishan has a comment, but P4 might be having many more enemies in house 1.
P4 might be having many more enemies in house 1. In house 1, see, Ishan, P4 can only have 3 enemies total. That is given in the question. Look at the question statement. Each member has at most 3 enemies. Now, if you tell me that P4 has 2 enemies in house 1, P5 and P6, then they can only have 1 more enemy in house 1. P4 has 2 enemies in house 2, P5 and P6. Then they can only have 1 more enemy in house 1. Because if they only have 3 enemies total. Right? 2 enemies are already known to him, P5 and P6.
Yeah, he said, I see.
Okay. So we are going to follow one. We could have followed any suggestion. We are just going to follow Brindway's suggestion. So P1, P2, P3, and this is P4. This is P5, P6, P7. So what happened? When we followed the suggestion, what would happen? So P4 now has 1 enemy in house 1 because P2 was an enemy, remember? And these 2 enemies, P5, P6, have been left behind. Okay, we have helped P4. But when we helped P4, P2 could be complaining because it was quite possible that P2 and P3 were connected. And here P2 and P3 are connected. So now, see, in the earlier configuration, in this configuration, P2 was happy. P2 is happy because he has only 1 enemy. Here P2 is unhappy. So although you made P4 happy. So see, this is a very similar situation to what you observed previously. We tried to make one thing happy, so P4 is unhappy. The other person becomes unhappy, right? P4 is happy. When we try to make P4 happy, P2 becomes unhappy. Now we can keep playing this game. We can keep going back and forth between P2 ko udhar dal do, P3 ko udhar dal. But okay, this is a extremality example. Do you see what this local improvement has actually improved? Can you see a parameter here which got improved? So let me make this visually a little bit less dense here. Okay. So what we did is simply took this P4 guy and we transferred him to house 1. Oh. Yeah, we simply transferred this guy to house 1. And this is the resulting configuration. Okay. But do you see a thing which got improved here? A parameter from the diagram which you think is increasing or decreasing? So yeah, take a minute. Think this, what you can visually see. It is not the number of unhappy or happy people. Because there you see P4 became happy, but then P2 also became unhappy. So that number stays the same.
Ishan is asking, what is the question?
Okay, the question is the following. I made this local improvement, Ishan. I sent P4 to house 1. I don't know what you meant by the question, the original question or this one. Let me say the original question first, then I'll say this one. The original question is saying that we can split the given number of people into 2 houses such that each person has at most 1 enemy.
He's asking this one, not the original question.
This question is that we help P4 by moving him to house 1. So P4 is happy. That made another person unhappy. P2 was earlier happy because he had only one neighbor P3, one enemy P3. Now he has 2 enemies, P3 and P4. So P2 is unhappy. We made an improvement for P4. We made a degradation for P2. The question to you is, while making this local improvement, is there a parameter you can see here which was increased or decreased? But let's say increased. Then you see a parameter here which was increased.
Shubhajit has a suggestion.
Yes, Shubhajit.
I can only see the number of edges between the 2 houses increasing in this particular example.
That is a great parameter. You can see that the number of edges between the houses, the number of enemy relations between the houses went up. Earlier there was 1. Now there are 2. There are other enemy relations which we haven't drawn, but they did not get disturbed. They did not get altered. The only enemy relations which got altered are due to the movement of P4. Right? P4 went from house 2 to house 1. The number of edges crossing the houses, the number of enemy relations across the houses went up. Earlier it was 1, now there are 2. And the other edges remain intact. They are not going anywhere. So the number of enemy relations went up. This is a clear parameter which increased. This situation is very similar to the situation in your previous question, where the most obvious parameter doesn't work, but there is another one which works. Is this clear to Ishan and Rinmay? Yeah. Number of edges crossing the 2 houses goes up.
Both are saying yes.
So the parameter is, and now it's plug and play, right? From this point onwards, you guys are now experts. This is plug and play. You start.
Let the plug and play. Let the plug and play.
Sorry, what are you saying?
Let them plug and play. Can they plug and play now? I want to see that.
Okay, so let me write the parameter and then you guys should be able to give a coherent argument with how the plug and play goes. Parameter is number of edges crossing. So now you guys know that if, so can you complete the argument from here? That's it. I'll not say anything. One of you should speak up just a broad outline or write it in the chat. Either is fine. all of you should write it in fact. That way you will know that you can actually follow it. And that's it. We'll be done for today's lecture once you submit your answers.
If it is difficult for write, because it might be a long answer, so you can unmute yourself and also say it.
Yeah. So once again, let me reiterate what the parameter is. So the parameter is that if I find a person like P4 who is unhappy in his house because he has two enemies, and he might have one more enemy in house 1 also, that's possible. But every time I shift him to house 1 from house 2, or from house 2 to house 1, whichever way, every time I shift him to the other house, those two enemies, those two edges are now cross edges. And this one edge, which was earlier a cross edge, the P4, P2 edge, is now an in-house edge. It's no longer a cross edge. But that's okay. I lost one edge and I gained two edges for the cost of. So the number of cross edges went up by 1. Every time I find a conflicting person, I make this maneuver, the number of cross edges goes up by 1.
It can also go up by 3. I mean, that can also happen.
Yeah, it can also go up by 3, but it will at least go up.
At least go up by 1 every time.
It will at least go up by 1. Right? So this to this is at least go up. It at least goes up by 1. Yeah, 3 could happen. P4 could be super unhappy. P5, P6, P7, all are its enemies. You change P4 to house 1, suddenly you have 3 crosses.
So then says, how does increasing the parameter number of crossings help us in proving the statement of the original question?
Okay, so that is what we will go over then. So, have the others submitted?
No one else has said anything. Only Mridma has mentioned.
So, okay, let's move along a little bit in this process. So, how would we do this? We would use our template. We want to say that it is always possible to split the two people in two houses. So, we start with a maximal configuration, right? We have realized that if it is not possible, we are able to make local improvements. We just saw that. So we start with a maximal configuration. Now, what is our parameter? Parameter is the number of edges crossing the houses. So we start with a configuration where the maximum number of edges are crossing the houses. So you start with a split where the maximum number of edges are crossing the houses. And then if you find a person who is unhappy, you will change the house of that person, create a new split where the number of crossing edges have gone up by 1 at least. It has gone up further. And this is a contradiction. So this is what we want to do. And I want you guys to tell me if you're uncomfortable. If you're comfortable, still I would advise you to type out the solution, at least some outline of it. Is this fine, Rinmay? Do you understand what's going on? So let me still write down these points.
And he said yes.
So what was confusing you earlier? Can you put your finger on that? Once we said that it's plug and play, what confused you? Start with a split into two houses, into H1 and H2.
So he doesn't understand what is plug and play.
Oh, plug and play just means that you plug your video game and you play your video game. What it means here is that you have a gadget, you have a framework in that you are now just going to input something to that framework and extract whatever comes out of it in a mechanical way almost. There is no further kind of thinking that you have to do. Start with the split into H1 and H2 where number of cross edges. So this is a symbol for number. Let me just write number. H1 and H2 with maximum number of cross edges. Max number of cross edges. If some person is unhappy, changing their house will increase the number of cross edges. That's so this configuration Thus, the maximal configuration has no unhappy person. Okay, so this is roughly what needs to be done. And with that,
Yeah, we think they follow. Everybody writing on the chat. So it seems by their comments that they follow.
okay, so we have taken this journey together, and now let's summarize. So here's what you guys should focus on. Try to learn the meta principles. Keep asking yourselves whether you have whether you have a consistent and coherent story to tell about the solution. When you read a solution, think about how you can generalize it. Will you be able to smell the solution next time such a situation presents to you? Of course, you will need to do a lot of problems. There is no shortcut. But if you do it this way, you will get the maximum purchase out of your problem. And we also learned for the particular technique of extremality, how to smell that, like in some sense. Of course, we have taken a few examples. We are not experts in extremality. There are a lot of innovative ways to use it, but we are getting started. And I feel the approach we did today should at least help you feel less intimidated by these solutions. So yeah, that's it. The lecture ends here. I'll stop the recording, and you guys can ask us questions if you have. Otherwise, you are free to go. Are there any announcements that you guys want to make?
Just there are. I'll have to do a few.
Okay. So I'll stop sharing first. And